All right, welcome to Module 4. This is our first objective, and we're getting into remote sensing, which is a little bit of a different concept compared to all the feature classes and everything that we've been talking about. We're actually getting into rasters now. So this particular or objective or video that you're watching is going to describe remote sensing and list advantages and disadvantages of it. So honestly, remote sensing is my background. I love remote sensing. I think it's probably one of the coolest things that you could possibly learn about. And and so here's a really great example of an aerial photo that has been taken of crops. And there's so much that we can learn about vegetation. There's so much we can learn about the Earth's surface, what humans have done on the Earth's surface, etc. So just by taking a photo, and then it's something that's captured in time and it's a long time standing. It's a great memory of that location. So we use remote sensing a lot in GIS because it is a real world capture of spatial data. So there are other things here, like so for example, this previous one shows us a visible light image, where if we go to this one, this is a panchromatic. And the reason you can identify the difference between them is because of the color, right? So a true color looks like this. And you can see that it's green where it's supposed to be green, red rooftops where it's supposed to be red. We call that a true color. And it uses the lights red, green, and blue. And then here is a panchromatic, which means that I only have a black and white image, or what we actually call grayscale in remote sensing. And so this one, you can see how the man-made features, such as buildings, are white. Because what it does is it takes a whole bunch of, like, the great big part of the electromagnetic spectrum and gathers all and sums all that energy that comes into it, into the sensor, and therefore it becomes brighter because it has more energy being released. So that's part of the reason why there. But so you can see, again, you can still identify the crops, and you can see that there's different types. It's just not as green as what it was before. But I could possibly learn something from the crops by looking at it. So for example, we can see this crop has a white spot there, this one even over here. And so it's some very interesting information that we would normally not see if it was green. And here's another example of looking at a flood. So capturing information, what did that flood do? What's the devastation of it? Where are the extents of it? And I can get these images really fast. It's not like trying to capture point data, going out and capturing it. And then here's another example of looking at vegetation. Perhaps this town is growing and we want to take a look at that and measure that. And we can see that there's a dark object in the center, which is probably water. It might be drying up. It might be because you can see vegetation within it. Perhaps it was the city's or this town's drinking water, and maybe this is that new blue algae that is showing up in there, and it's causing them not to be able to drink that water. We can also see a river that's been dammed, and then it gets much smaller over here. So again, another thing that we can watch and see in our images. So with that, I can go and I can identify different edges, different polygons, different lines. So you can see here in this example that somebody has digitized the image to create polygons and lines to identify different features. So what remote sensing is, it is a fundamental source of data in GIS. So whether it is in the form of, well, it says GPS data, but that's not necessarily, it's kind of remote sensing, but it's more imagery or altitude. But you can consider GPS data because it is technically from afar, but you have to be in the location to be able to capture it. So a lot of definitions don't include GPS data, but some do. But technically, if you have to go to that location to get the information and be like actually on the ground like you would with a GPS, then it's not technically remote. But definitely imagery or even altitude data, because you would use an altimeter for that. Now, information from remote sensing is usually incorporated into GIS, and it has a really informative, comprehensive GIS system when it has that information, just because remote sensing is so much more powerful in terms of the information that it can gather and the ability to capture something real time. So it is a method of acquiring and processing information and the data using a device that's not in direct contact with the feature. So that's what I just said, right? The word remote. But remote sensing is not limited to Earth-related remote sensing. We've got the James Webb telescope that we use that's way up in space, as an example. And we can even say like the observatories on Earth are remote sensing to space because we don't actually go to the star to capture that data. So some examples of remote sensing methods is satellite weather maps, speed radar measurements, graduation photos, sonar. So we definitely, right, because again, you're not going to the object. Hospitals using imaging technologies, so medical imaging, because you don't cut somebody open to see whether they broke a bone, for example. CAT scans are medical images. Same with MRI is also a medical image, and same with X-rays is a medical image. And you can actually use microwaves as well as medical imaging, and gamma rays for medical imaging. So we can kind of keep going there. There's lots and lots of different things that we can do. If you've never had one of these done, just take a look and just Google the name because honestly, they're really, really powerful. But again, medical imaging is not necessarily a GIS thing, but it uses the same idea. So for example, here is this image below of a soil temperature probe, a form of remote sensing. Well, no, it is not, right? Because of the fact that it actually has to go into the soil to be able to detect that temperature. So the use of remote sensing data within GIS, it's across the board. It's used in pretty much every industry, environmental, archaeological, cultural, geological. Remote sensing really tells a lot of stories, and so we can use it in any industry. So GIS and remote sensing have been combined into what is referred to as geomatics. That's as a geomatics expert, that is not what it is. Geomatics stands for Earth, and then matics is measurement. So geomatics is the umbrella of GIS. GIS is actually a subcategory of geomatics. It's just a tool that we use in geomatics to be able to come up with an answer. And remote sensing is the same thing. It's a tool that we use in order to come up with an answer. But technically, when you do a GIS, you are learning a pillar of geomatics. So it's kind of written backwards in this particular PowerPoint. So geomatics, we take everything, right? So we take GIS, we take aerial photography and aerial surveying. We do airborne and satellite remote sensing. There's global positioning systems, computer visualizations and display. We use GPS. We use total stations. We use all kinds of conventional surveying. We use a lot. so geomatics itself is all of that, and then takes into and does the, if you do geomatics engineering, then it's actually the building of the methods that allows us to integrate all of this. But you can also use it to come up with the solution. So as we read through here, I'm gonna give you a chance to read it, and I want you to think about why you would use remote sensing techniques and determine how it would impact that project. So I'll read it out, and then you can pause, and then we'll talk about it when you come back. So you work for a forest company and need an inventory of recently purchased timber block in a rugged area of British Columbia. You need to know the extent of merchantable timber and to estimate the cost of harvesting that timber. One option would be to send the GPS-equipped field crews to count the trees in this 100-hectare block. This approach would involve a substantial labor cost, a $1,500 per hour helicopter rental, mobilization charges, food and lodging costs for the crew, transportation to and from the helipad, and insurance for the employees in the field. Field data may be uploaded directly from a laptop or handheld digital device, but it may also require some time-consuming manual input from field data. So, So you can pause here and think about it. Think about what the other option might be. And that would, so pause. Now that you're back. So with this, remote sensing would make sense because I can use an aerial. I can do, for example, $1,500 per hour. I would have an airplane go over, come back, take a couple hours to process that data, and then when it comes back, I can give it to my boss and say this is what is there. So it is much faster. It is, you don't have to worry about remote access. It's there for you in terms of an image, or in this case, I would recommend LiDAR, which would be because it can penetrate the tree canopy, so I'd get even more information about the trees. So some considerations is the energy source. So there's a difference between passive and active. So passive sensors means that we call it one-way ranging, or that they only detect energy, so they don't actually produce their own. You can consider them as like a regular camera without a flash. So there's no flash on it, just receives. Our eyes are also passive sensors, so we just receive data. So it measures energy that's naturally available, so we don't actually have to enhance that energy, and it just is there for us to capture. So we can only use passive sensors if the energy is there. so if the sunlight is there, we can see visible light. And same with infrared light. If we want to use thermal infrared, we need to have heat being produced, otherwise we won't see it. So what does this mean for daytime and nighttime? Well, obviously the sun needs to be there. Otherwise, if I do it at night, all I can see is city lights. And maybe that's what you're trying to see. And that's okay, right? Because that would be what you were measuring. The other version is an active sensor, and so this is a camera with a flash. So it's not our eyes, because our eyes would be like laser beams that shoot out everywhere so we can see. So it doesn't work that way. But an active sensor does. So they're also known as two-way ranging as well. And so they emit radiation, or send out their own energy, and then that will reflect off the target, and then it'll come back. So radiation from the target is detected and measured by the sensor, and that's what's most important. So for example, if I send out like a LiDAR, for example, and it hits this object, it's going to bounce off the object and it's going to return back. And then this one would also have the LiDAR, and this one. Here, if it's not in the view, then it's not there. But you can picture it as, if we have the camera here, send out the flash, it hits that and it bounces back. So some of the advantages and disadvantages of this. So there's a few, of course, right? So consider aerial versus satellite, passive versus active. So aerial versus satellite is right. Oh, let's go back here. So some advantages of aerial versus satellite. So aerial is going to be closer to the ground, so you're going to see more detail. We can also use more sensitive or less expensive equipment, I would say, but it is more sensitive, so I can actually get more information because I'm not having to deal with an entire atmosphere. For satellite, I'm having to deal with an entire atmosphere to get my data. And then also with satellite, it's much further away, so I get a much larger footprint, which is an advantage, but I also get less detail. So aerial photography can get to about an accuracy of about 5 centimeters, where satellite imagery, the best we can get is about 30 centimeters. So it gives you a little bit of a perception of between the two. And then some advantages of passive is I don't need an extra source of data, and so therefore it doesn't make it as complicated. Where an active sensor, we have a more complicated system, so it's going to cost more, but I can do more with it. So for example, we use microwaves in the Arctic, The reason we use microwaves in the Arctic is because during the summertime, there's a lot of cloud, so we can't use visible light. But during the winter time, it is dark, so therefore we don't have natural light. So we tend to use microwaves for that. And it's the same with South America as well. So Venezuela and Colombia tend to have a lot of cloud, and so therefore they use a lot of microwaves in order to do mapping and GIS work with the remote sensing data. So remote sensing is a method of acquiring and processing information and data using a device that's not in direct contact. Passive sensors measure energy that is naturally available. Active sensors provide their own energy for illumination. So there's a few links in your PowerPoint. Definitely take a look at them. They'll give you a little bit more. They'll give you some images that you're welcome to download. There's no exercises, and there's our references again. So that's a brief introduction to remote sensing.